And thanks to everyone for viewing this session on a closer look at A2L refrigerants. Now, during this presentation, you're going to hear me use the word flammable. So for everyone to better understand how the refrigerant industry utilizes ASHRAE Standard 34 to identify refrigerants into specific flammable categories, we need everyone to understand some of the tests utilized, like the two shown on the screen. Now, for an ignition event to ever occur, you need three things. You need the right concentration of air and a fuel, and in this case, we'll use refrigerant. And then you need a strong enough ignition source. Now, if any of these three conditions are not met, then there will be no ignition event. So let's go into more detail about these industry tests. Now, please note that for many of you, this session is going to go much deeper into refrigerant testing than anyone has ever presented, so please follow closely. Within the testing of every refrigerant, a globe is filled with refrigerant and air. Next, a high energy ignition source is utilized to try to ignite that refrigerant to see if it will produce a flame spread. For a refrigerant to maintain an A1 classification, the flame spread within that vessel cannot exceed the 90-degree parameter represented by that blue V shape shown in the black box. Now, as the refrigerant is ignited, you see that within this image, the flame spread stays within that 90-degree parameter. It's important to point out that the refrigerant did ignite, but it stayed within that 90-degree parameter. Now, a quotation from the Firefighter Safety Research Institute training on refrigerant safety verifies that A1 refrigerants like R22 or R410A will burn under the right conditions. So, while the industry has stated for many years that the refrigerants like R410A are non-flammable, the correct ASHRAE Standard 34 definition for an A1 refrigerant is no flame propagation, meaning the flame did not spread beyond that 90-degree value. Now, while the image on the far right doesn't appear to be too different from the Class 1 image, remember that 90-degree value is the deciding factor between no flame propagation and flammable. If the refrigerant spreads beyond that 90-degree parameter, represented by the orange V shape, the refrigerant is now classified as flammable. The image in the far right shows an A2L refrigerant. The next slide, we talk about the flame spread. Once that flame spreads beyond the 90-degree value, there's actually three levels of flammability. The chart below shows the Class 1 image. It shows the refrigerant groupings per ASHRAE Standard 34 that are focused on that flammability. Now, let's take a moment and discuss the myth that all flammable refrigerants are the same. They are not. The 2L category is the lowest level of flammability of those three. Now, it's a stark contrast to Class 3 refrigerants like hydrocarbons or R290, commonly known as propane, which is shown in that last image on this slide. Class 3 refrigerants tend to propagate much more easily. So now that we've introduced propane or R290 into our discussion, we'll show there's a significant difference between an A2L refrigerant like R454B and an A3 refrigerant like R290 or R600. So let's begin the comparison. Opteon XL41 or R454B has an A2L classification. As you've heard earlier today, this is the refrigerant most air conditioning manufacturers have selected as their R410A replacement. R290, commonly known as a hydrocarbon or propane, is a highly flammable refrigerant, which is why this refrigerant has an A3 classification. Now, to continue our presentation, let's begin our discussion on the differences of flammability. Now, remember the three circles that we discussed on that very first slide, and that it takes just the right concentration of fuel and air to even have the potential for an ignition event. Now, the industry calls that beginning of that right concentration the lower flammability limit, or LFL. It is that minimum concentration of a refrigerant in air that is needed to propagate an ignition. If the concentration never reaches the LFL value, the mixture will not ignite. The chart shows that R454B has roughly 8 times higher LFL value on a mass weight basis compared to R290 or propane. And that higher value can have a big impact on risk because as the LFL of a refrigerant goes up, this means that the system would need to leak out more refrigerant within a certain space to ever form a flammable concentration. Now, if we reach that LFL value and we get to that flammable concentration, then we need to be concerned about potential ignition sources. The industry testing term used here is minimum ignition energy, or MIE. On the chart, you see the energy to ignite the right concentration of propane is 0.25 millijoules. I mean, therefore, propane can easily be ignited by low energy ignition sources, such as something as simple as static electricity. Versus an A2L MIE is orders of magnitude higher, which again has an impact on risk because as that MIE value increases, there are fewer potential ignition sources that can ignite an A2L refrigerant. As part of the industry's preparation, Chris said it as well, for the A2Ls, many tests have been shown just how hard it is to ignite an A2L refrigerant versus an A3 refrigerant. Now, unfortunately, we don't have time today to go into details about burning velocity and heat of combustion, but equipment manufacturers will follow the latest UL and ASHRAE standards to build equipment so the LFL values are never reached, or that there are no ignition sources that have high enough energy anywhere near the refrigerant sources. And this slide highlights some of the strategies from the latest UL or ASHRAE standards for designing and installing A2L equipment. Now, how equipment manufacturers choose to design their equipment from reaching LFLs or isolating ignition sources, these things will be discussed during their Opteon XL41 equipment training. So let's do a quick summary of an A2L versus an A3 refrigerant. First of all, A2L refrigerants are less likely to ever get to the flammable concentration, which will allow an A2L refrigerant to be designed into a wider variety of equipment. And even if the situation would allow for an A2L refrigerant to make it to that right concentration, it's much harder to get the concentration to ignite. Simply put, many of the electrical components, sources, or electrical tools used in the field will not ignite an A2L refrigerant. Bottom line, while the EPA's approved list of replacement refrigerants for R410A do have a different ASHRAE Standard 34 classification, for many systems, equipment designs will not be dramatically different associated with equipment utilizing these A2L refrigerants. So from that, send it back to Chris.
Awesome. Thank you so much. There's so much to take away from that, Jeff. I really appreciate it. Some of the most impactful points for me are how similar the A1s and the A2Ls actually are. I think that we do have some time for at least one question. I'll make it a good one. Jeff, do you know when the current residential building codes are going to be changed to allow A2L refrigerants?
Yeah, that's a good question. That's probably the most popular. So A2Ls are already enabled in a wide range of applications in the 2024 I codes. So A2Ls are currently enabled in machine rooms in the UMC. There's several proposals further enabling A2Ls were approved by the UMC Technical Committee that was done in May of 2021. And then there's also several states like Washington, Oregon, Florida, North Carolina, that have already enabled the use of A2Ls. And so we fully expect other states to follow suit. So that's kind of a short answer, but it is complicated, but it's moving quickly.
There's a lot of activity over there. I really appreciate it. Thank you so much for your time this afternoon, Jeff. And also, thanks again, Esther and Chris, for your input into today's event. We appreciate it. All right, this brings us to the final portion of the event, which is the event raffle. The raffle winners have been selected at random from the group that registered for this event. We've had some fun planning the prizes, and I'm excited to announce the results. Okay, here are the winners of our event raffle. Starting with the Opteon gift bags, our lucky winners are M. David Burdett, Kevin McElvany, and Debbie Rowland. Congratulations, guys. Moving on to the center, the winners of the Opteon branded Mammoth coolers are Jerry McNavish and Adam Dorenzo. Awesome. All right. And thanks to our partnership with the National